and welcome to an asynchronous lesson where we're going to be thinking about how we can use changes in a climate model to better understand how human activities and human solutions can better improve the overall temperature in Earth's atmosphere, and what those trade-offs of cost, severity, frequency, and amount might have to play with our future. So earlier in class today, we talked about how there's lots of different ways to think about solving the carbon crisis, whether it's new technology, replacing bad habits with new habits, or doing things such as planting trees or restoring natural ecosystems. And we talked about how there were some behaviors that we think are too important to simply ban, and there's some activities like eating cows that maybe we should try and limit. And within all of these different solutions, whether it's reforestation or trying to help glaciers not melt or making people drive new cars, there are trade-offs in terms of the positive aspects on the carbon cycle and maybe the things that aren't going to help the carbon cycle, or at least not create a positive change. Now, as we've talked about, the amount of CO2 and other greenhouse gases have gone up quite a bit in the past 150 years due to human activities. And with that, we have seen a reasonably stable temperature of about 13.7, 13.8 degrees Celsius, or about 52 degrees Fahrenheit, really start to pick up as well. And the temperature anomaly in the past 30 or 40 years have really risen from what pre-industrial levels have been. So part of your task today is thinking about where do we get a healthy temperature to, and how are those steps going to be implemented by humans? So within our first carbon modeling cycle, we set up Earth as it is, 425 parts per million, 5 clouds, an albedo of 0.3, and we basically said humans don't solve the crisis, where we added 0.05 as an albedo every 6,000 ticks because of deforestation, soil degradation, ice caps melting. We added more carbon dioxide, 25 parts per million every 2,000 ticks, because in this scenario, human populations rose and we kept burning fossil fuels. And also things like soil degradation meant that it was harder for us to store carbon in the soils. And then we also increased clouds every 3,000 ticks because we were having increased temperatures. So more water and melting ice caps would evaporate to form more water vapor. Now, there's 3 types of analyses that you can use today with your solutions. The first is just citing the shape and changes, the max and the mins in your slopes. So you can read this as an XY scatter plot, where X is going to be time and Y is going to be temperature. You can use the slope of different sections of your graph to approximate the rate of change. And that's always going to be y2 minus y1, x2 minus x1. And it's really easy to find those data points, especially at places where you make changes. And you can also look at percent difference. And that's where you take the difference between 2 values and you divided it by their average. Now, with this, you are going to start making some scenarios in which you make changes. So within your Google Doc, down here, you have solutions. So you're going to be proposing one solution and a second solution, where after 18,000 ticks at this scenario, you're going to start making changes. And you're going to want to put your graph here at the end of 36,000 ticks. So you're going to let this run for 36,000 ticks. And you're also going to want to record the changes that you make. So at tick 0, I'm going to say for my first solution, I'm going to reduce CO2 by 25 every 2,000 ticks. So I'd say tick 0 is going to be, this is really 18,000, it would be down to 375. And then at tick 2,000, it would be 325, and so on and so forth. Now I'm going to open my net logo, and here is my carbon model. It's at tick 17,756, so it's basically 18,000. And when it reaches 18,000, I'm going to remove some CO2. And we're just going to simply let it run. And we can notice that the temperature really hasn't changed much. Now I said I'm going to change it by 50 every 2,000 ticks. So when we get to 19, or when we get to 20,000 ticks, I'm going to remove even more CO2 down to 325. And you could think about the things that humans would have to do in order to remove CO2 from the atmosphere. We might have to ban beef, limit transportation, reduce electricity use, develop new technologies. Are all of these new costs and technologies worth the temperature savings? So I'm at 20,000, so I'm going to reduce it even more. And notice my temperature hasn't changed much. We're at 58. The goal is somewhere around 52 or 53 degrees, and it's still not changing that much. So I'm going to be patient. Maybe at this point within human activity, maybe we ban beef entirely. So we're really trying to bring our CO2 levels down. Maybe everyone can only drive cars, not trucks. We're really trying to be thoughtful of our use of CO2 emissions. And at 22,000, which is about to be here, I'm going to remove even more CO2. So we're now down to 275. The temperature has gone down to 59, but notice we have a couple problems. A, the surface of the Earth is still pretty warm, so we're radiating a lot of heat. We still have a lot of CO2, so a lot of that heat is still being trapped. But I do have some clouds which are making the incoming radiation not as great. And now we're starting to see a pretty dramatic decrease to 53. We've lost a little bit. So I'm going to pause here at 24,000. And I'm going to take a look at my chart, because this is going to be where I get my data. So remember that at about 18,000, we were at 59. Oh, here's 18,000. At 18,000, we reduced CO2 levels from 425 to 375. And I saw a drop of about 56. So 3.5 degrees by reducing that CO2 levels by 50 parts per million. And then it started to rise just probably due to natural fluctuations. And at about 20,000, I was back at 59. I reduced CO2 levels again, and it really didn't change that much. We dropped about 1.5 degrees. And then at 22,000, I dropped it even more, and that's where I started to see a really large precipitous drop. So when it comes to citing information in here, I can talk about specific values of CO2. I can talk about ticks. I can talk about changes in slope, thinking about x and y values. And I can also look at the percent difference in temperature for different changes. This data hopefully is going to allow us to start to think about the big questions that we're going to be answering towards the end of the year. What are the solutions and what are the problems that we really care about within the world of carbon? Do we worry more about industrial emissions or cows? Do we worry more about solving transmission or transportation emissions, or do we worry about planting forests? I hope this lesson helps solidify some ideas when it comes to how you can use this modeling activity. And if you have any questions, please let me know. I'm really looking for some specific data citation, so feel free to use all three types of these analyses to really hit home how different changes impacted our solutions. When it comes to the second model that you do, try and take whatever you did in Model 1 and vary it somehow to see how differences in frequency and variation impact it. You can change the amount of CO2 that you emit, the clouds or the albedos, and you can also modify the ticks. How quickly do you make those changes? Have a great day, and I'll see you soon.